Okay. All right, guys. So today I'm going to do a quick lesson here as best I can on the introduction to acid and base formation and a little bit on neutralization. So here we go. First of all, acids are anything that form a hydrogen ion. So since hydrogen, which in this case it has one proton, then it's an H plus ion. So that's what this will represent. Then what we need to realize is that acids are only formed in solution. So that means that if we add acid to water, okay, then we end up with plus H2O. What we're going to end up with is something called hydronium, which is H3O plus. So what that looks like is this guy just simply adds on to the water, and then when we have three hydrogens that are attached to our oxygen. Now, just as a real quick reminder, which you may or may not recall, oxygen, because it's number 8 on the periodic table, it puts 2 electrons in the first orbital or shell that we want to, they're flying around. Then there's 6 left over that can be somewhere around here. 2, 3, 4, 5, 6. And this level right here holds 8. Okay? A total of 8. So in order to get 2 more, since these guys are negative, it would become a negative 2. And you can actually see those negatives right there and right there. And now it looks like a dead Teenage Mutant Ninja Turtle, or one just holding his breath. So anyway, the point that I want to make here is that because oxygen is -2, and that's in chemistry we might call that an oxidation number, that its goal is to gain 2 electrons. Well, if you recall, hydrogen, on the other hand, is +1, and opposites attract. So really what that plus means is the hydrogen wants to give an electron away, the oxygen wants to gain 1, and so if we do that twice, we get a Mickey Mouse Giants fan. No, I'm kidding. But we end up getting this negative and this negative get neutralized or balanced out by this positive and this positive, and that's why water does not have a charge at all. It's not an ion, it's a molecule. Okay, so we end up with a water molecule that is made up of 2 hydrogens and 1 oxygen. So when we add the third hydrogen to it right here, the only thing left to do, it doesn't matter where it goes, just for today's lesson, we end up with 3 H's. Okay, so we have 1, 2, 3 H's. We have 1 O, but we also have this plus left over. So it ends up with H3O plus, and that is called hydronium. Okay, that's how we get an acid. So acids, you might say, are things that have H plus in them because they're going to add to water and end up making hydronium. All right. Now, some specific acids would be if I take hydrochloric acid. So I always do that. Let's get rid of that guy. If I take hydrochloric acid, which is HCl, okay, chlorine's a little bit bigger, hydrogen, chlorine, and I add that to water, which I don't have up here, but I can make it real quick. So there's my oxygen. Okay, there is my hydrogen, and there's my hydrogen. So if I add HCl to water, what's going to happen is when it hits the water, these guys ionize. So we get a negative chlorine and a positive hydrogen. Then this guy is going to attack the water, and that right there is our hydronium. Okay? Now, whoops. What this chlorine ion right here usually has something else to bond to. We'll get to that a little bit later. So that's kind of how acids are formed. So they ionize when they hit water. The hydrogen grabs onto a water molecule to make hydronium. Okay? So what happens to bases? So a base, let me get rid of this guy. What happens with a base is kind of similar. So bases usually are bringing, lost here, bases kind of bring the base to the party. And so since I don't have this one, I will, oh, where is it? I'm just going to draw out, let's just say that this guy right here is sodium, okay? Now, sodium is Na plus. Na plus. And I know that's not easy to read, but whoops, let me put that back. So this is Na plus, sodium, and sodium makes something called sodium hydroxide, all right? Na and OH. So we can write that this way. I'm going to write it in blue, sodium hydroxide. Now hydroxide is actually a negative ion and sodium is a positive, and that's why they attract each other. But let me break this guy down for you just a minute. So hydroxide is 1 H plus and 1 oxygen. So if our OH here, look at what we did. We have 1 negative taken care of and 1 positive canceled out. So what we have left is we have O right there, and we have H up there in red, but we also have a negative. You can see it right there. So OH minus is hydroxide, okay, right here, hydroxide. So sodium hydroxide is a base because it contains hydroxide. All right, so acids have H plus, like a hydrochloric acid, and bases have OH minus, like sodium hydroxide. So the one thing you might be noticing at this point is that H and OH can go to make water. And so I already have that for you up here. There's my acid. I'm going to write it in red. There's acid. What is that? That's H plus, okay, hydrogen ion. Over here's our base. Whoops, I already have it written. I'll just do that. That's hydroxide right there. So what happens when we add an acid to a base? It neutralizes and forms, you hopefully have guessed it by now, that guy's gone, that guy's gone, that guy's gone, and what we have left is water. So water is a combination of an acid and a base. It's equal parts. They cancel each other out. And so water is not an acid, not a base, neutral. Okay? Now, the last thing that I want to get to here, let's see if I can do this real quick, is I'm going to put all this down at the same time. No, that's not what I want to do. I want to clear the page. All right. So let me go back to just my molecules or atoms, ions here. So here's my hydrogen. That's acid. Here's my hydroxide. That's base. And I'm going to use two very specific ones. So I'm going to take this. I'm going to say, all right, I have hydrochloric acid. This guy right here is chlorine. Okay, so I have hydrochloric acid, HCl. Actually, I don't want to do that. I want to write it in red. HCl. There's our acid right there. I'm going to add to that, okay, sodium hydroxide. And because I keep forgetting to make my sodium, I guess I'll just grab one of these guys from up here, and we'll just draw it out, sodium, and then we'll grab a hydroxide, okay, and I'll put it in there, Na plus, and that's OH minus, and you can see there's our base. What that's going to give us is And you can see it, H and OH right here and right here. And they're going to go ahead to make water, H2O. So the negative ion from right there and the positive ion from right there cancel each other out. And that's why right here, there's no plus, no minus. But that's gone. That's water. So we've just neutralized our H plus and our OH minus. What we're left with is an Na plus and a Cl minus. Those two guys, you can see it, are opposites, and we end up with NaCl, or sodium chloride, which is table salt. So, last thing I want you to get out of this is this right here. Let me get rid of that one. And that is a salt, whoops, sorry about that, is any ionic, okay, what that means? It's formed from ions, any ionic compound formed by a neutralization. What's that mean? That means it's the process of neutralizing reaction. And what does that mean? It means we are neutralizing, really it means this, acid plus base gives me water and salt. Not always table salt, but some type of salt. Water is, another way I could have said it, is neutral. So instead of being an acid over here on a scale or a base over here on a scale, so if here's acid and here's base, this would be neutral, and we are moving these two to the center to make water. All right, I hope that's helpful. I know it wasn't quick, but I hope it helps you understand.